So bsc first year, same one. Continue. Unit 1, second chapter now. Means complex circular and hyperbolic function. Okay, next topic. First, already we study de Morgan's theorem. Okay, on this. So first, okay, definitions. Complex circular function first of all, and then hyperbolic function. So let z equals to x plus iy be a complex function, base number. Then we define sin z. Okay, sin of z, sin z. This is e raised to power iz minus e raised to power minus iz divided by twice I. Okay, sin function, sin of z. Sin will be e raised to power iz minus e raised to power minus iz upon twice I. Similarly, cos z. Cos z will be e raised to power iz plus e raised to power minus iz upon 2. Okay, so sin z minus subtraction of this, but upon twice I here, and cos z plus, cos then plus, sin then minus, but sin then twice I, and cos then only 2. Okay, so other similarly, tan means sin by cos, and z will be sin z upon cos z as usual trigonometry. Okay, so these two main definition in a circular function. Now you know results. To verify result, is maybe for 2 more question. You know, sin square z plus cos square z is 1 in mathematics. So with this, prove this. Prove that sin square z plus cos square z, of course 1 must be verified, because this is standard trigonometry we study from the 8th class. Okay, so this must be proved here also. Using this, okay, so let z equals to, you know, x plus iy be complex. Only I want z, I don't want x plus iy, so z will be complex. Then we know this by definition. Okay, we know sin z, we know cos z. Okay, and we have to prove sin square z plus cos square z will be 1. So take left hand side, sin square z plus cos square z, and this will be 2. So sin square z, sin value e raised to power iz minus e raised to power minus iz upon twice I. Cos square value e raised to power iz plus e raised to power minus iz upon 2 squares. So square, first of all denominator 2 square 4, and I square minus 1, e raised to power iz minus e raised to power minus iz whole square. Also here 2 square 4 and e raised to power iz plus e raised to power minus iz whole square. So LCM 4 means here minus sign, okay, or okay, these squares. So first term e raised to power iz whole square minus 2 times e raised to power iz e raised to power minus iz plus e raised to power minus iz whole square. First term minus sign for the 3 term. Next 3 term square e raised to power iz square plus 2 times e raised to power iz plus e raised to power minus iz and e raised to power minus iz square. Okay, sign change. So minus e raised to power iz whole square minus minus plus 4 times e raised to power iz e raised to power minus iz e raised to power 0 minus e raised to power minus iz whole square and this line. E raised to power 0 again iz minus iz. Okay. So what is it? Minus and plus term cancel, minus and plus term cancel. 2 e raised to power 0 1, 2 e raised to power 0 1 by 4. So 2 plus 2 4, 4 by 4 1. Okay, so solving trigonometry apples. So sin square z plus cos square z equals to 1. Hence proof. Also second trigonometry also we know. In always in mathematics prove that sin of minus z is minus time sin z, you know, and cos of minus z is cos of z, same. Okay, this is also trigonometry in mathematics. Sin of minus z is minus time sin z and cos of minus z same as assumption. Proof. So we know then sin of z e raised to power iz minus e raised to power minus iz upon twice I by definition. I want now minus z in place of z minus z. So replace z by minus z. Sin of minus z in e raised to power in place of z minus z, in place of z minus z. So what you see, e raised to power, which is minus iz, e raised to power minus minus plus iz upon twice I. So in definition, e raised to power iz plus term first and second term minus. So the first term is plus. I want means what? Minus sign common or minus 1 is common. So e raised to power iz minus e raised to power minus iz divided by twice I. So minus sine, and now remaining by definition is sin z. Okay, so therefore we have sine of minus z is minus times sin z. So this trigonometry we know always. Sin of minus cx minus times sin x. Okay, so his proof for this also circular functions. Now second cos, similarly for cos. So you know cos formula, cos z e raised to power iz plus e raised to power minus iz by 2 by definition. Same, replace z by minus z. So cos of minus z will be e raised to power minus z e raised to power minus z by 2. This is same as e raised to power minus iz plus e raised to power plus iz by 2. So this I want plus term first. So a plus b or b plus a, no problem. In the plus, no problem. In the minus, problem. Okay, a plus b or b plus c, no problem. Okay, so this is again original cos z. Okay. So cos of minus z will be cos of z. So this is both the formula mathematics proof using this definition of circular functions. Okay, so this is about the circular function, complex circular function, not real sin x, cos x, tan x. This is called z, sin z. Z is a complex. Now second comes to the main point. What is a hyperbolic function now? So again first of all the definition and then again results. So same, let z be a complex function, of course x plus iy if you want. Then okay, hyperbolic side. Hyperbolic sine of z. Hyperbolic sine. Okay. Sine of z, you know sine z. And the hyperbolic sine of z is defined as, so sine hz, or you can say sine h of z. Sine z circular function, trigonometric function. So sine h of z will be here e raised to power z only minus e raised to power minus z upon 2. Okay. So in the circular function there is a iz, e raised to power iz. Here no I. In hyperbolic no I. Okay. So sin z is of course same, sin then minus and cos then plus. Cos then plus e raised to power z plus e raised to power minus z upon 2. Upon 2 upon 2. There is no I. In circular, is it twice I. So here no I. Okay, so this only two definitions. Now examples, results on this. First main results. Okay. So you know trigonometry. Okay. Sin square z plus cos square z is 1. Or theta sin square theta plus cos square theta is 1. Okay, this we study from the 11th class, 8th class. Okay, this is the trigonometry circular function, but in the hyperbolic difference result. So in the trigonometry hyperbolic not same result, hyperbolic. Okay, in hyperbolic cos h square z minus sin h square z is 1. Trigonometry sin square plus cos square 1, the cos square plus sin square 1, sin square plus 1 plus. Okay, but here remember minus, and cos square minus sin square, not sin square minus cos square is 1, no, cos square minus sin square is 1. Okay, so remember difference trigonometry in hyperbolic, or every formula in hyperbolic difference trigonometry, not same in trigonometry. So first of all, prove this. We know this formula first of all. We know. Okay, sin z this and cos z this. Okay, now so take left side, we have to show cos square minus sin square is 1, cos square z minus sin square z is 1. We have to show. Put cos square value e raised to power z plus e raised to power minus z by 2 minus e raised to power minus z upon 2 2 square 4, and square of this e raised to power z whole square plus, or directly so 4 is LCM, 2 and 2 times e raised to power z, e raised to power minus z, e raised to power minus z whole square minus whole square e raised to power z whole square minus twice e raised to power z e raised to power minus z plus e raised to power minus z whole square. So e raised to power z whole square means e raised to power 2z, e raised to power z minus z 0, e raised to power minus z whole square means e raised to power minus 2z, sign change e raised to power again 2z minus minus plus e raised to power 0 z by 0 e raised to power minus 2z. So e raised to power 2z cancel, minus 2z cancel, e raised to power 0 1, e raised to power 0 1 4, 4 upon 4 is 1. Okay, so in this way result will be cos square z minus sin square z will be 1. Okay, so remember in hyperbolic function difference relation, difference identity. In trigonometry already we know sin square z cos square 1, but here okay, minus. Again other relations. Prove that sin of iz equals to I times sin hz. So relation of circular function with the hyperbolic function. So sin of iz is I times sin hz, and cos of iz is cos of hz. So this is now new relation, right? Not in your class, 8th class, 7th class. Okay, this is new result in bsc first year, new. Okay, before that we will not study this result. New results. So relation of circular function and hyperbolic function, both. Circular function sin of z, hyperbolic is. So I want sin iz. So we know sin z, trigonometry, sin of z is by definition e raised to power iz minus e raised to power minus iz upon twice I. This is relation by definition. Now I want sin of iz. So replace z by iz. Okay, in place of z, iz. So in place of sin z, iz. In place of z, iz. In place of z, iz. So e raised to power I into I square z. E raised to power minus I square z. I square, you know, I is a under root of minus 1. So I square will be minus 1. So e raised to power I square is minus 1 minus z. E raised to power actually plus 1 e raised to power z upon twice I. So minus plus, I want plus term will be first. So I take minus sign common. This minus 1 is common. So e raised to power z minus e raised to power minus z divided by 2I. Now minus 1 means I square. I square. One I cancel. I. Okay. And now this e raised to power z, e raised to minus z upon 2 is what? By definition. Okay. Is a sin hz. Hyperbolic sign, minus means sin. Okay. So sin of iz, then I times sin hz. So this is relation circular with hyperbolic. So sin iz is I times sin hz. Okay. So this for sin proof. Now similarly for cos proof. So we know cos z is plus and no I. Cos no I. So replace z by iz. Sin iz. I square minus I square, I square minus 1 minus I square plus 1 by 2. This is same as e raised to power z plus term first minus term second. So this is cos z, cos h z. Okay, so cos of iz will be cos of hz. Second proof. Next problems on this. Separate into real and imaginary part. Real and imaginary part. Sin of x plus iy, tan of x plus iy. Separate real part and imaginary. Real part no I, that terms will be real. Imaginary I containing that will be imaginary parts. First, so sin of x plus iy. Here what is real part and what is imaginary part. So sin of x plus iy, sin a plus b formula, sin a cos b plus cos a sin b. Okay, sin of a plus b, sin a cos b cos a sin b, sin x sin x. So sin of iy, just we have relation sin of iy, the cos of iy cos hy, same. And the sin of iy is I times sin hy, sin iz I times sin iz, I outside, and cos of iy equally a. So real part, this will be real part, sin x cos hy, real part. Imaginary part I का multiple, imaginary part. Imaginary part होगा cos x sin hy. Voilà, bonne B part tomorrow.